All right, next up we have ionic compounds. And remember, ionic compounds are made up of cations, which are positively charged, and anions, which have negative charges in them. And they're generally made out of metals and nonmetals combined together. So for example, table salt is sodium plus and then chloride minus. And so unlike molecular compounds, which exist as separate molecules, ionic compounds don't. So they don't exist as separate molecules, but rather as crystals with repeating units. So for example, here's the structure of sodium chloride. I think in blue is the sodium and then in green is the chloride. And what you'll notice is that any one of these, in this case, chlorines, is not just bonded to one sodium, it's actually bonded to all of the sodiums that are right next to it. So although we write the formula as NaCl, it's really more of a lattice of different compounds. And so since all of these are bonded to one another, they stick to one another really well. They generally have high melting points and boiling points compared to molecular or covalent compounds. Of course, there's kind of a little bit of a trick question here that we took a look at earlier. We can have both ionic and covalent bonding in a molecule. So for example, something like ammonium nitrate, right, is made up out of our polyatomic ions, ammonium, which has covalent bonding in it, and then nitrate, which has ionic bonding in it. I'm not going to draw the lone pairs just because it's a lot of dots, but you get the point.